Okay. Okay. Let's do a simple detail of a slab. So we assume the slab, uh, let's see a slab that is going to capture some of the, the, the types of details for slabs that we have looked at. So we need to look at one that covers a simple end support with no restraint, and then a restraint section is so that you can easily figure out, because if we show it on plan you can't see how far. It would be difficult to understand here, like to see the bottom, the top, how they are bending. Yeah, yeah. So it's easier to show this way. So we can try do a simple slab, a simple slab layout that would capture these items that we have looked at. So let's do something like this, like that. So let me draw it. So let me draw it. Let me set layers 1 to 50. Let's say you have something like units and millimeters. Okay, fine. So line offset LO. Or I can even use this one, LO. That's going to take some time. Okay, LO, so 3000. There, say 3000. 4000. That way, and maybe 3000. Hello, Junior. So LO, 100. Let's draw the slab. LO 100, LO 100, LO 100. So I'm trying to create 100. The beam. Okay. Okay. For that, LO 100. So LO 100, LO 100, LO 100, LO 100, LO 100, and LO 100. So let's see our slab, our beam are passing there. LB. See, let me remove line thicknesses, line widths. So LB, line box, LB. I can press F3 to repeat command that way. Let's also create some center lines. So we come here and get the center line there. Here also we get the center line. We choose pen. Let's work with pen 1 for center line. Yes, yes, sir. Right. So let's work with L1 for center line.
Hello.
LO. I'm doing LO. So LL. Get it there. LO. There we are. Oh, we still have one more to go. So there we are. So we want to detail this slab. So as you notice, let's have a cantilever. We need a cantilever as well. So let's have a cantilever. And this is 2 meter. There. We have a cantilever. That way 2 meter. So slab is there. Line get, line set, LS, LGLS. So we have that, and we have a cantilever coming out there. So if this is the cantilever, so so let's do these beams dotted, hidden lines. So to show how to properly detail them. So I did LG, I came here, chose that, hidden, then LS, then I applied. Let me do that again. So I came here, chose a hidden line, and then type L, type S. Then you click, 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 click to apply properties. Line set properties. Okay, now you will notice, let's see if all our items are covered. So what we don't have is a simple end support with no restraint. So let's have that as well. Isn't it? We cover everything. So a restraint end support, we have several of them here. And then continuous internal support, we have cantilever, we have, let's see, we have a cantilever. We have a cantilever there, and then so let's see, let's check it then. So we have a cantilever, we have a continuous internal support, continuous internal support, simple support, no restraint. This is the one I want to add somewhere. Simple support with no restraint. So what we do, simple support with no restraint, maybe this side, let's say it's this side, the beam ends here, then there's a wall, isn't it? So the beam comes and ends there, that way. Then there's a wall below. Maybe we can hatch to show the wall. We get hatch, sorry, H. Let's get hatch parameters HP. We choose, this is good for wall. So we type HH. Or let's choose the correct pen for the hatch. Maybe it's a solid pen, not a dotted one. And even you can choose pen 1. So we say HH. You see that? So let's try L. what I did is click there, edit info EI. So I'm going to change the scale factor to about 10 so that it looks like that, or even 20. EI, change the scale factor into 20. There we are. So here we have wall. The beam is not passing there. The beam is not just a wall below. Yes, so that place the slab is going to behave differently. So let's start with an assumption. Yeah, it's just a cut. There's no beam around. It's just a plate. Yes, just the slab. No beam around it. Yes, and it's too. How much is that? 2 meters is too much for a single plate. 1.5 is okay. Let's do 1500. Otherwise, you would need a beam round there and here and there. So let's do 1500. Okay. See, we extend this there and extend that there. Extend this there. Yes. So after that, we are going to now do the details. Which one? Okay, let me redo that. And to move it back, I type ES. Click, 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 click. Everything you want to stretch. Edit stretch. Click there, and it moves behind. So EX for extend. EX for extend. Okay. Yeah. Okay. Okay, fine. So from there, we going to go into the detailing. Go into the detailing of a slab. So we have to make a few assumptions. Let's say we have done our analysis, we have done our design, and what remains is to detail. Let us assume that we have gotten, let me try if I can write. So let us assume that, wow, I thought our pen is writing. AS or for the bottom is maybe 450 millimeter square. That's what we have. Let's also assume that AS, well, 450 is quite high, but let's work with it. Let's say AS for this this beam 1, call it beam 1, along beam 1, text, I could even type, let's say text angle 0 TA. So let's also say AS TA. AS for the, yes, yes, I type TA and then put the angle. So I type TA and I put 0. Yes. So let's say AS for the main, call it main beam, What happened? I've stopped the recording. Did I?
No, it's okay.
Okay. So AS
So you did
uh, wait, for the main beam along the main beam, AS along beam is, let's say, 600. So let's say 600 millimeter square for slab top. The top, that's a slab top, is 600, and AS, okay, let's say an AS for the slab top along the other beam is, let's say, 500 millimeter square.
Just
We're just assuming. So what we are saying, so reinforcement required here and here, bottom one, is 450, both directions. And the reinforcement required for the top of slab along here is 600, and along here is 500. So we need to also say text parameters. Let me do that. TP, I type TP, TT, so I've typed TT for text. So I want to do the reinforcement AS, that's the AS for the top of the slab and the cantilever is, let's say, 700 millimeters square. Those values are for a really heavy slab. So we work with those, work with that. So we come here and start with the bottom reinforcement. So bottom reinforcement, both direction, 450 millimeters square. So how much is 450 millimeters square? So if you are using tens, 10, let's go to the calculator. A 10 is 78.5. So 450 divided 78.5, you need 5.7 pieces per meter, isn't it? I copy that. So 1,000 divided by, wow. Okay. How much? What was that? 5.6. 5.6. So 178 spacing. Say one. Let's say 150 or 175. So 175 spacing of tens. So what we're going to do is, for the slab, you remember this thing here. So this end is a restrained end, restrained end support. So we are doing this 100%. So we're gonna get the center line offset 0.1 of L. You see, 0.1 of L. So what is our L? L is from here. This dimension sorry, DH, click there. So you went from there to there to there to there. So our span here is dimension horizontal. We could even LY, click there, LY, DV, click there, click there, click there, click there. And the overall dimensions again, DV, D vertical, click there and click there. Facing. So here DH to get the overall dimension there. You see? So that way we we have our dimensions in place, and so let's do the detail for the bottom reinforcement going that way. So we look at this restrained end support. It's restrained because there's a beam here. It's restraining the slab. You see, it's restrained. So at that point, there are things we need to take note of. One is 0.1 L. So our L is 3 meter. 0.1 of L is 300. Good. So we come here, click there, LY, I've typed LY, LO, offset 300. So we add our rebar to start here. So, but this is a cantilever end. Wow. Okay, fine. We have another a continuous support here. So let's trace the bottom reinforcement again at the continuous internal support. We need the 0.2 from center line. Yes. So 0.2 L. L is 3. 0.2 of L is 600. So we come here, we offset 600. So according to the code, you need to put a reinforcement starting here and ending there. You see? So let's put that reinforcement. I clicked there. I click there. I do a construction line LX. So I'm going to put reinforcement RB. I type RB. So we have reinforcement here, and we say it's tens at 175. So I'm going to create a bar mark 01. Bar mark 01. See? Diameter is 10. Type of steel, user Y. And then we have to specify cover. Cover for the slab is 20 everywhere. See, 20 top, 20 bottom, 20 sides. So I pick this rebar. It's a straight bar. Yeah, we need a straight bar. We take this bar, but you notice, let's check again. We need a straight bar 100%, then 40%. Our AS, what was our AS? It was 450. Was it 450? Let's see. 450. So what is 40% of 450? So let's check it again. Yeah, 450 times 0.4. Sorry, 450 multiply 0.4. 450 multiply 0.4. 180. So what's 180? 180, if you divide by 78.5 is 150 divide 150 divide 78. Okay, 180. 180 divide 78. 180 divide 78.5. 180 divide 78.5. It's like 3 pieces. So 2.2. 1,000 divided by 2.2. That's 500. 1,000 divided by 2.2 is 400 and something. What's this? Divide by 2.2. It's 500. 1,000 divided by 2.2 is equals to 454. You cannot space 454, otherwise we'll get problem with the curve. So I would prefer to space maybe 250. 250. The U bar now. It's going to 250. So this ought to be 250. The other one. But you remember. So let's place the bottom reinforcement first. Let's just place this bottom reinforcement. I would prefer not to leave such a big space. I'd rather take this to the end. The code says 600, but I'd rather take this to the end. So let's break that rule and offset here. Take it 50. It says point 0.2. Notice 0.2 maximum. So you can make it smaller. So we have chosen smaller. So we are still within. Yes, just offset 50. Let's say the maximum.
So that means you can do
Less. Yes. 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 So maximum. So let's do that. I will prefer another 50 the other side. Yes, let's do panel by panel for now. If there would we need to do something different, we can assess. But let's try to stick to the code as much as possible. So this also was saying 0.1 maximum. Let's do 0.1. I mean, oh sorry, 50. 50 offset 50 there. Let's see. So let's do our rebar from here to there. RB, this one. Let's check rebar parameters. RP, we want to use pen 6 for rebar. Pen 6. Okay, let's do RB again. Pick that. Starting there. Wow. And there it has reduced bar with cover. I didn't want that. RB. Let's not reduce with cover. Mark 0, 1, because I can specify the covers myself as I'm detailing. So I'd want to automate cover provisions. I start there and I end there. So beautiful. We have reinforcement at that place. So let's say this reinforcement, we require it all the way. So I'll click there, type LY, and pick that reinforcement. To distribute the reinforcement, I'm going to do, let's work with R5 to distribute the reinforcement all through. So type R5. Click there, R5. Okay, let's click there, type R5. Okay, so we're starting this zone there, from there up to there, from there up to there. So escape. text position, I'll put text there. So this is tens spaced at, we say 175, 175, and is the bottom one, B1 is the bottom one. You see there. Click. Do you want shrink group ends with cover? Yes, I'm going to shrink the group ends with cover. So TM. Wow. Let's redo that. Let's redo that. RB, and the type, we missed that. This was bar mark 1, 0, 1. Let's pick the rebar. This one is already there. Okay. Click here. R5. See? Zone start. There. Zone end. There. Zone start. There. Zone end. There. And then we don't have another zone. We escape. Where do we want to put our text? Put the text there. What's the spacing now here? It's 75. Is a bottom one, but you can change here. So enter. Shrink group ends with cover. I can say yes, just to have a better detail here. You see? So I already have something in the bar bending schedule. So I'll replace, because we are redoing. Replace existing line. So TM for text, move there. There's something on something that we didn't do correctly. Again, EI. This is a Y bar. We can even make it a D or whatever you want. Yeah. What you write here is what is going to display the type. What is going to display there. So the bar has changed, the type has changed. So let me quickly redo that. R5. There, click there, click there, replace existing line, TM. See? I think. So we have this reinforcement shown there. Yes, I have that reinforcement shown. So we want to continue with the bottom, this section. It seems we might not finish detailing the slab today because we're explaining a lot, but let's do the next part of the bottom. You see, we have done this. We have done this only. This one coming instead of 0.2L. We have done minimum. So we need 40% of AS here. 40% of AS. So we need to put reinforcement here of 40%. But normally, good practice, okay, I prefer to provide this same reinforcement all the way past the beam. Yeah, provide past the beam. So that instead of 40%, you have 100%, because it's saying here 40% minimum. So you can provide more. Yes, just to simplify our detail for today. Listen. So I'm going to take this 40%, 300 inside, so that I can provide for. So let's see. 40%, I'll take it 300 inside. So what we have provided is that we have taken this well inside. So I'm going to stretch this bar. To stretch the bar, I have to type Rx. Rx. I pick this bar and stretch it up to that point. The bar has changed. I've taken care of the bottom here, but just by doing that. You see. And then I'm going to now do the bottom for this panel. Because it is same, you can even take this bar up to the other side. But sometimes it's not same. A different its own. So let's do its own. So in the same way, let's offset here ly lo 300, and I start click there lx. I start another rebar here up to there. But because of this beam, I need to provide a bottom for it. Let's extend again 300 that way, because 300 will be beyond the beam. ly 300, that's my practice. Maybe somebody might have something else or more, but that's what I usually do. So we have this going 300 beyond, and we have this here up to that place. So let's put in the rebar. We set same requirements for area of steel. Assumption, that is an assumption. So
Otherwise, you get from your calculation of your numbers.
yes. So RB, you see, let's see, RB. So bar mark number 2, we had already put number 1. Same reinforcement
The cover.
there. We're not reducing with cover, because we can do that with on the detail. Click there, start here, end there. You see? So we have that reinforcement too. So let's distribute that reinforcement. Click there, type ly. So to distribute, click on the reinforcement R5. So there's a question here, zone start. So it says so that zone starts there, reaches there, starts there again, goes up to the far end, and then is that the end of its zoning, the zones? Yes, click there. Text position, I'm going to put my text here. 175 spacing is the bottom one, yes, and there. You see, so you see here it's telling you you have 39 wide tens.
It took place
Yes, with 02. So it's 22 pieces, 17 pieces. Yeah. Yeah, but yeah, it's a little automated. It's automated. That's the bottom. And so let's do for the end of the slab. You remember this is a cantilever. So if we check for the cantilever, at the bottom it says nominal use minimum tension unless specified. So we use minimum. So here I want to put even 8 at 250. So I can offset ly lo 300, and I put 8. Click lx rb. I changed this to 8. Bar mark 3, still straight bar starting there up to the far end. Wow, I didn't cover. Let's redo that. RB, this was 03, reduce with cover. And pick that. up to the. Now I need to reduce with cover here now.
Yeah.
So fine. So the rebar cannot reach the far end. We need a cover. LO 20. Come here. ES. Type ES. Click here up to that point. ES to stretch. Click there, there. To update. Yes, to update it. So we want to distribute this one here. This is a bottom rebar.
Then we have to distribute it.
This is a bottom rebar. So you click here L1, R5, start at the far end, all the way to the far end, escape, type escape. I can put my text position, I can even put my text here outside. So this one is spaced at 250 and is a bottom one there, and there are 30 of them, 8 at 250. So I have put my bottom rebars that are going this direction.
That's bottom one.
Yes, bottom one go in that direction. So let's put bottoms in the other direction.
Yes.
Bottom rebars.
So here the 300 we're using it here,
Huh?
but we're using it there. The 50, we're using the 50.
Because here the slab is continuous and I want this rebar to cross to the other side.
Yeah.
Yes.
We're going to use 50 there.
You can't choose 50 now, because if I use 50, it would either come here. The overlap between this and this is going to be so small.
So the 50 use at the edge.
Yes, at the edge. At the edge.
Supposed to end at 300. You end
Yes.
Why you want to go to 300?
Yes, like at here, at the end, you just use 50. But in the middle, cross the beam with the 300. Is it? Cross the beam with 300. Okay.
We finish all the bottoms now.
This direction. We have bottoms the other direction.
Yeah.
Just
Then it becomes the tops.
yes. So let us, to simplify our work, let's do one bottom going all the way. Isn't it?
Is that the vertex we use?
No, let's do the proper thing. Let's have a bottom up to there and another bottom there. Okay. So as we said, LX, LO, I do 300. Now do quickly the same thing I've done the other side without explaining much. LY, and then I'm going to do RB. This is bar mark number 4. That's correct. Now this is a 10. Reduce the cover. I'm going to start here up to that point, and I'm going to distribute LX. So R5, that's the bottom. Escape. Let's do that. R5.
We're using the 2 panels together.
Yes, the 2 panels. Yeah, the same. This panel, we said the requirement is the same all the way. So I put text here. Bottom to less 175. Bottom to 175. 175. Bottom to that way. So we have this one there. You see there, 175 bottom
The
2.
sizes you adjusted the text or it adjusts itself once you use.
Let's see the text. We are using our text is a little bigger. We can edit the text a little. Text parameters 2.5 is okay for here. 2.5. Then text set TS. I set like that to reduce the text, the middle text. So dimension parameters DP. Let's say work with 2.5 that way. So we have put that detail, the bottom there. We need the bottom for here, for this side. So I'm going to offset 300 LY RB bar mark number 5. This is a 10 there. Up to that point, I'll click here, LX, click here R5, text position. There we are. Can we move this here? Yes. So we have done the bottom there. So let's do the bottom of the cantilever. So the bottom of the cantilever, the bottom 2, let's say is also 8 at B. This is 8 at 250, starting there and ending there. Escape, click there, LX. Yeah, R5. Here, spacing, text position. Let's do that again. R5, escape, text position 250. This one we offset with cover. That's okay because it's going to the end both sides. Bottom 2. There we are. So we have that. Yeah, all bottoms are in place. So let's do a top for this part. Mostly it will be same as top for that part. But let's do top for this top, the main top part for this part, the top one for this part. So one thing that we need to
Number one is the main, number two is the
yeah, so this is the main top. The other is going to be the distribution. There's a top one and there's a top 2. So the top one is the main top, the other top is the distribution. Yeah, so let's do the main top, this one. So that one, check again, is a continuous internal support. We're going to stagger 100% for the top here, AS for the top of the slab 700. So what is 50% of 700? Is 350. So 350, a calculator, I hope it's going to behave. 350 divided by tens, 78.5 is equals to 4.45. So 4 divided by 4.45, 224. Say 200 spacing. Say 200 spacing. So what we do, we are going to look in 0.15 L. Are you seeing that? 0.15 L. 0.15 L from the edge of a support. So what is the L? LX of LX is the greater of adjacent spans. So we have two adjacent spans. We have 3100 and we have 3,000. So 3,100. So 0.15 of 3,100. What's that? Calculator. 0.15 times 3,100. Sorry. 0.15 times 3,100 is 465. You see, 465. So let's say 500. Also, you need something that can be properly measured on site. So let's say 500 can be easily measured on site. LO 500. There we are. LO 500. So LO 500 twice. So what we're going to do, click there, type LX. So the first rebar, one which we are staggering, RB, is at 10, bar mark number 7. Pick this one, starting here, ending there. You see, let's do that again. This will cover, pick that, starting there, ending there. You're seeing that? And then LX, similar, the same rebar, B3, starting there, ending there. I copied it, so it is staggered. So I have to show DH, this distance here, DH, that distance there, let me do that again. DH from there to there to there. DH. Okay, just a moment. So what I keep BB, pick B3, you take wherever you want it. Let me redo it. You understand that? Okay. So DH for dimensioning. Okay. So we want to distribute these ones. Want to distribute these ones?
Together.
You know what we do are there's the staggering. This one. So let's see. Normally there are different ways. I normally don't use that stagger command, but let's try it today. There's a way. There are many ways of staggering. Okay, let's try ly. Okay, let me ly. This is where I want my dimension line to pass. So R, I typed RT for staggered bars. What I have to do, what we may have to do, just pick this rebar and distribute. You see, distribute, isn't it? Distribute R5. I mean, pick this rebar R5. Start there, and end there. So the spacing, what spacing do we get? 200. And no, we got it 200 for so it's in the middle is 100 where they meet. So we're going to space these ones at 100. We space at 100. So start, escape, text position here. We space at 100. This is a top one. Yes, are you seeing that? So TM, we have that rebar there, 28, 66 there, 66. So now this one, you have to pick this and include that because they are both of them. Right? See, the 07, and then you have to say top one staggered. Staggered.
Repeat how you include that one and how you edit the text.
We were at that point. This text, this dimension line is picking this rebar, but it's not capturing this other one. So I type BB, pick this, click here, click there, B3, escape. So you have shown that this dimension line is picking this rebar and that one. Now you need to say that these and these are staggered. So edit info, STG. Edit info is EISTG, that way. So the other option you have to achieve the same result, well, there's another option, is to have, let me do construction lines here, demonstrate, is to have this rebar longer this one shorter, but they have different mama. You see, you will achieve the same result again if you stagger them. You achieve the same result. I'm saying, if I can just sketch, what will happen? What will happen is that in the first case, you have reinforcement. Let me draw better. Do a better drawing. You have reinforcement like this. I know I can draw better, so that's why I'm not satisfied with the drawing I've done. So you would see that in the middle here, the spacing is double. Outside the spacing is half this one. But you can achieve the same result by doing this. Check. You can also achieve the same result by doing this. You see? Yes. So you can use both. So the same thing. Same thing. Yeah. So that's why I said you can either do this or you can either do this, or let me do the construction lines again. Yes. Or you can either do this. This is this one,
Yeah.
or you can do it RX to extend back, RX to extend, or you can do that. Same thing, same result. Yeah. So at least today we have looked at. Sure, you want to start?
The cantilever.
Okay, let's do the cantilever, the top for the cantilever. So the cantilever, you notice that for the cantilever, um, for the cantilever, there we are. We need uh, we need to know point 3 of L and 0.15 of K, which is greater. Are you seeing that? So 0.3 of L, this is L is 3100. You see? So 0.3 of L, that's right here. L,
Finish as quick as possible. I mean, rest.
so 0.3 of L. Okay, or can we? What time we're finishing?
No. Yeah.
So if we can, it will take us some time. The cantilever. We can do it later.
Tomorrow.
Yes, tomorrow.
Okay.
So at least we can stop there for today. Then we continue our detailing for the slab.